The last section of the appendix in our textbook, A3, is titled Fractional Expressions. We're going to look at first is how to find the domain of algebraic expressions, which will include fractional expressions. We'll spend the bulk of our time how to add, subtract, multiply, divide rational expressions, also just how to simplify and reduce fractions. And then we'll look at an example or two of compound fractions. First, let's look at how we determine the domain of an algebraic expression, as this will ultimately lead to finding the domain of functions later on. When we talk about domain, we really mean are what are the values x can be. Okay? And oftentimes we answer that question by determining, are there any values that x cannot be? And then we just kind of throw away those values. Okay? Now, typically there are two things that are going to restrict domain. And those are highlighted or discussed in these two examples. Typically, square roots are common expressions you're going to see that are going to restrict domains. And then we have fractional expressions, which is what we're dealing with in this section. You'll have restricted domains. Now in this first example, 2x squared minus 3x plus 4, we don't see square roots, we don't see fractions, therefore there is nothing that's going to restrict the domain here. I would list the domain as all real numbers. Or we can write it negative infinity to infinity. Okay? In other words, I can put anything in for x that I want. It doesn't matter if it's positive, negative, fractional, zero. Put anything in that I want. It's just fine. Okay? In the second example, because we have the square root, there are some problems inherent with that square root. We all know, for example, that unless we're opening this up to, you might remember from Algebra 2, if you're opening this up to complex or imaginary numbers, we know that we cannot square root negatives. Okay? Can only square root numbers that are greater than or equal to 0. Okay? So let's begin by figuring out what's the smallest number x can be. Okay, what's the smallest value that x can take so that, in other words, x minus 3 becomes 0? Well, what number minus 3 is 0? That's easy enough to answer that it's 3. Okay, so x can be 3, because that would be the square root of 0. Then x can be anything bigger than 3. Say x was 4. 4 minus 3 is 1. I can take the square root of 1. X can't be anything smaller than 3, though. Say x is 2. I get 2 minus 3, that's negative 1. We can't square root negative 1. So my domain are all real numbers greater than or equal to 3. Better way to write it would be with interval notation, 3 to infinity. Square bracket on 3 means we can include the 3. Okay, so x can be 3, anything towards infinity, beyond that, anything bigger than 3. The final example, dealing with the fraction. With the fraction, we're concerned with dividing by 0. Can't divide by 0. Okay, so that's the concern. We have to throw away anything that causes us to divide by 0. So just mental math is easy enough here. What number plus 5 becomes 0? And the answer is negative 5. We have to throw away negative 5. So our domain is all real numbers not equal to negative 5. Or I could write negative infinity to to -5 or -5 to infinity. So it's not negative to positive infinity as in up here, but essentially it's negative to positive infinity with -5 thrown out. Remember, the rounded brackets mean don't include that number. The only number I'm not including is -5. I'm including everything else from negative to positive infinity. Before we get into operations with fractions, let's look at just how to reduce fractions. If all the terms, if the entire problem is built upon products in the numerator and denominator respective, then all we're going to do is reduce the fraction like we would any fraction. I'll go ahead and write this out. I'll overkill it on this example just so we can see things cross out, but it's much simpler than even this. 3x to the 5th is 3x, x, 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 and x. 18 could be 3 times 6 times, and there's two x's, x times x. Okay. Now we're just going to cross out all the common factors. We're going to reduce them out. So the 3's go away, x for x along the way, and what's left over in the numerator is x to the 3rd, denominator is 6. Of course, 3/18 reduces to 1/6, and if I subtract powers on the x's, 5 minus 2 is 3. That's the faster way to do it. Now, if we're looking at a problem as in the second one where you've got plus and minus signs on the numerator and denominator respective, well then we first have to write it as a product, okay? Just as we wrote this as a product. The way I write it as a product is to factor. The numerator, I see a common factor of x. Take an x out, it leaves x minus 3. The denominator, we see that there is no common factor, but it's that two-term difference of squares pattern. X times x makes x squared, 3 times 3 makes 9, 1 plus 1 minus, and then we cancel out anything that's common. X minus 3 takes out x minus 3, and so we say the answer is x divided by x plus 3. Sometimes you'll even see this added to it. You'll see added to the answer x not equal to 3. It looks like x could be 3 because if x was 3 here, it makes 6. It's perfectly fine to divide by 6. But up here, what I canceled out, x couldn't be 3. 3 minus 3 would have made 0. Divide by 0. So sometimes you see that whatever you canceled out up here, we add what that restriction was, what that domain restriction would have been. So you see that a little bit too. Maybe not so much in Algebra 1, Algebra 2, but often in this college algebra course you'll see that as well. When we multiply rational expressions, do not, I repeat, do not just start foiling the top together and foil down here on the bottom and just kind of go crazy multiplying everything together. Instead, factor everything. Okay? So this first fraction, (2x squared plus 11x minus 21). There is no common factor, so I'm going to start with 2x times x. I need two numbers that multiply to this one and add to this one. Okay? So let's see, we're going to go with, looks like 7 and 3, so that when I FOIL, the outside, the 2 and the 7 make 14, the inside, 3 and 1 make 3. 14 minus 3 would be 11. So I want the 14 to be positive, I want to be subtracting 3, so the signs go like that. Second one, it's actually a two-step process. I need to take an x out. Notice there's an x in everything. If I take an x out of everything, so that's gone, this is gone, this becomes 2. So now we're going to factor into the binomials x squared plus 2x plus 4. Okay, well that would be x times x, and then multiply to 4, add to 2. That's not actually possible. Okay? It's not actually possible, then I can't really do this. So maybe I should have just left it the way it was. Let's rewrite the numerator. Denominator, I can take that x out, but then it's going to have x squared plus 2x plus 4. Okay. Numerator of the second fraction, two terms, they're cubes. So that's the binomial trinomial pattern. Cube root of x to the third is x, cube root of 8 is 2. I square the x, I square the 2, I multiply them together for the middle, same, opposite, always plus. If you memorize the pattern, you can do it that fast. You want to get that good at it. And then the denominator, x squared plus 5x minus 14. There are no common factors. So let's just factor it. X times x is x squared. Multiply to negative 14. Adding to positive 5 is going to be plus 7 minus 2. Okay. Now, since we are multiplying together, anything that's common is going to cancel out. So x plus 7 and x plus 7 are out. X squared plus 2x plus 4, those are out. X minus 2, those are out. So my final answer is going to be 2x minus 3 over x. Next example, when we divide fractions, there's really nothing special about it. It's not that much more difficult than the multiplication problem we just did. We just have to remember our rule. When we divide fractions, we change to multiply by the reciprocal. Okay. So I'm going to begin this by just factoring everything. When I get to that division sign, then I'll do this over here, and I'll just keep factoring. X cubed plus 1, two terms, they are cubes, binomial, trinomial. X and 1 are the cube roots. X squared and 1 are the squares. 1x is the product. Same sign, opposite sign, always plus. Okay. Pause it, go back and rewatch it, check it if you need to. X squared minus x minus 2, there are no common factors, so I just factor it as it is. X times x is x squared, minus 2 plus 1. So negative 2 and 1 multiply and add correctly. So now here, this division changes to multiplication. This fraction reciprocates, flips over. That's all we do. X squared minus x plus 1 is going to go down here. Notice I didn't even try and factor it because it's common with this. They're going to cross out. Okay. X squared minus 4x plus 4 does factor. X times x makes x squared. If I minus 2 and minus 2, I'm going to multiply to 4 and add to negative 4. Okay. Now we can cross out anything that's common. So these trinomials that don't factor are out. X minus 2 here are out. X plus 1s are out. All that's left, all by itself, is that x minus 2. No denominator, so I don't have to divide by anything.